we're going to do a small presentation on the project, about the project. So stating the objectives, the scope, presenting the consortia, so who are the partners in this project, and the specific elements of the project. So, and of course, give some space also to have a nice conversation with all the participants today, to see if anyone can contribute, gives their feedback, their insights on the project objectives, and hopefully this project can be built for the next 2 years or 1.5 years, more or less, built with strong connections to the community. So without further ado, sorry, let me just, so today I will give a brief introduction to the projects, so the motivation mainly, also the project objectives and scope, give an outline of how we see the project, so in a nice picture how all these parts come together, and then I will pass over to my colleagues that will explain specific elements of the project. In the end, then we'll also have space for, the small discussion on the demonstration projects that we will be doing within this project and within the Circular EcoBIM. And then we will leave some space, some time to have hopefully a fruitful discussion. So coming to the introduction, I think for all of you, this is perfectly clear. I don't want to spend too much time on this, but I think everyone agrees that the construction sector is one of the most material and energy intensive, well, at least material intensive sectors in the economy. It also represents, in terms of the use, during the use phase, it also represents a high energy footprint, and of course, naturally, then carbon footprint. And then, and just because of the sheer volume or impact of this sector on the environment, it has called for different environmental assessment approaches. So we know that there's a lot of work on the environmental assessment of the buildings or the construction sector, and taking this as a base, specifically the use of LCA for the construction sector, using this as a base for our own, let's say, approach to this topic. We thought, well, this part is getting consolidated, so we have a lot of literature, we have a lot of the state-of-the-art in LCA applied to the construction sector is established. It's arguable, but let's assume that. And for us, it was more about start thinking about how circularity can come to this discussion in a robust and scientific way. And of course, applying this to tools that can be used by architects, by building managers, etc. And so with this in mind, we started thinking how we should start building these tools. And of course, the first intuition was using BIM tools. So integrating BIM tools with environmental assessment tools. And of course, we, in this case, 3 drivers, are more experts on the environmental assessment part. But we are friends with all of the other participants in the consortium. That are experts on BIM. And so we joined together and started thinking about this Circular EcoBIM project. And so the main question was, of course, as I said, we already have some knowledge, we as a consortium have some knowledge on the integration and some practical examples of integration of BIM and LCA. And we wanted to take a step further. We wanted to start talking about circularity, so how we can bring these concepts, and as consultants in this area of circular economy, we understand that the concept is there. There's very nice discussions on circularity for the whole economy and also for the construction sector, but we felt that we needed to take it a bit further and have more practical approaches. And that was basically the motivation behind the project. We started thinking about, so we had this opportunity that I will discuss it in the next slide, but we had this opportunity to apply for support of the EA grants. And we started thinking, well, the call asked for specific approaches, practical approaches to very concrete aspects of the construction sector. And so we basically integrated or aligned our ideas with the call. And we proposed the Circular EcoBIM project with 3 specific and interconnected tools, basically a database of construction materials and products that includes circularity indicators. So it will advance in terms of including more indicators that are related to circularity in the construction sectors. Also plugins that could build on the existing tools like Revit and other tools for BIM that could take this kind of data from the database, this information from the database, and calculate indicators, integrated indicators for buildings, for projects. And then a third tool, the digital twin platform, so that will enable building managers, but also architects to have a more integrated 3D vision on these objects that and the environmental assessment metrics. And so all of these topics will be discussed by my colleagues. The database will be discussed by my colleague Verena. Then António Aguiar Costa, and she will also talk about the calculation of circularity and the use of the concepts of design for disassembly. António Aguiar Costa will talk a bit further about, we'll talk about the integration of LCA in BIM, which is basically the backbone for the whole calculations. And then my colleague Rui Barata, I'm saying colleagues, but my friends, in fact, will talk about this issue. He will talk about this digital twin platform. All of these tools will be built and applied or demonstrated in 3-4 projects, building projects, and we will have Vic Properties talk about 4 projects, I think, that they and Ateliês Remédios, another partner in the project, will be doing for the next 1.5 years. And so the project started in August 2020. We took this time also to consolidate the objective, the scope of the project. And so today we will be presenting all of this. And the project will run until July 2022. So just to quickly mention the partners. We are 3 drivers. We are an environmental consultancy company, so focus on environmental assessment. We are, for the past few years, we've been working on this concept of circular construction. We have Central BIM that they are focused on building BIM models and all of the services that go along with it. Of course, we have IST, top engineering university or school in Portugal. We have 2 departments, IN+, more focused on the environmental assessment, all of these industrial ecology approaches, and also Ceres that has the expertise on BIM, but also on LCA applied to the construction sector. We have Vic Properties. They are developers, one of the biggest or most dynamic developers in Portugal at this time, with several large-scale and promising projects in the Lisbon area and other areas. So they will talk about the specific projects that they will allocate to this Circular EcoBIM project. Then we have Ateliês Remédios. They are an architect office that won one of the most prestigious prizes in Portugal, the Valmor, Prémio Valmor in 2011. They also have, Francisco will be here today to also, Francisco has given the opportunity to present just for organization's sake. Vic will present Ateliês Remédios project, but Francisco is here today, and I'm sure he will be happy to give some insight on the specific projects that he will bring to the table if someone wants to know more. And we have the Norwegian partner, NTNU, which is also one of the top scientific and engineering schools in Norway. We have Helga and Rolf. They are from different departments, and they also bring a more industrial ecology perspective to the project. They will be, I would say, more scientific advisors to the project, and so help us deliver all the results and achieving the objectives we have proposed. And Rolf is more specialized in the civil construction sector, and so we, as IST, we have 2 different insights or 2 different perspectives that we have brought to this project. And so I also want to acknowledge the support naturally of EA grants. EA grants is, as most of you know already, probably, it's a support, a funding mechanism, yes, that is results from the partnership between the European Union and Iceland, Liechtenstein, and Norway. And so we are happy to have their support on this for this project, and hopefully we can also help to the EA grants achieve their objectives in promoting the sustainability of, in this case, in this specific call, it was for circular construction. Hopefully we can contribute to their objectives also. And so before I pass over to Verena, I just want to give you the outline of our project and how these different components integrate themselves. So we will start by discussing the database, because it will, in terms of how the information flows, it will be mainly the start of the project, or the basic element of the project. And so this database will include all the information that is necessary to calculate the indicators, circularity indicators, life cycle assessment indicators, etc. We are building this database with information that is already available in other databases, but we will also include information that we'll be doing for the next 1 year, 1.5 years. We will be approaching specific case studies and calculate all the necessary information, or extract the necessary information for building this database of products, construction products and elements. So from there, of course, we will integrate information from EPDs, and that was mainly the external data that we'll be using for this project. So this part, of course, is outside the scope of the project. Basically, we'll be using existing BIM platforms, and from IST, they will build plugin applications, and these plugin applications will be useful to calculate indicators, levels. Here, levels is basically a small set of levels indicators that will be the result of the calculation of the LCA calculation. And then we are also discussing the use of circularity indicators and circularity passports for buildings and for construction elements that will somehow also influence the design of the database. All of this information then will be used at this digital twin platform that I mentioned. And so giving users, building managers, architects, etc., a more friendly way, let's say, a more interactive way to deal with all of this information that these plugins will be producing. Okay. So, as I said, my colleague Verena will be talking a bit more about this database and how to calculate circularity indicators. Then she will pass over to António Guerra Costa, that will talk about the integration of BIM and LCA. And then we will hear from Rui Barat and his views on the building of this digital twin platform. In the end, we will come to Vig Properties will present their views, their projects that will be used as demonstration projects for this, for the EcoBIM, Circular EcoBIM project. And finally, we will come back to me and I will introduce the Q&A session. So, Verena, I think that's your turn.
Yes. Hello. My name is Verena Gößwein, and I'm going to tell you a bit more about the database and then also about circularity indicators. So this is our vision for what we want to create in terms of database, which is an important feature of the BIM platform that we want to build. And that is because it contains information and it organizes the information, and in that way it will enable the calculation of the different plugin applications in this automated BIM environment. So the plugin applications, as Antonio referred to, are circularity passports, and then also indicators from the new European levels framework. We want to have an inner architecture of the database that will allow for better organization of the data. So you can group that in 3 big groups. The first one would be, we want to include data from other existing LCA databases. So a good reference here is the German EcoBIM database that includes thousands of entries for different products and construction materials. Another good source of LCA result data are environmental product declarations. So we want to include EPDs from Europe, especially from Portugal. So even though the selection in Portugal at the moment is still very limited, this will be one of our focuses to push that a bit forward, the availability of data for Portuguese construction projects. And for that reason, we also want to include more specific lifecycle inventory data. Another feature of the database will be that we want to feed it with examples of typical construction of Portuguese buildings. So for example, let's say of a typical wall assembly. The idea is here that if you apply BIM and LCA during the design phase of a building, usually you're confronted with the problem that it would be better to apply it at an early stage of design, but at that moment the level of detail is still very low, so you might not know the exact design of the building, and particularly not the products and the materials that you will use. So we want to provide examples of what it typically looks like, so that the architect or the person that is using the BIM platform can use that to kind of estimate and compare different design alternatives. Next slide, please. Antonio, can you change slides, please? Yeah, thank you. So I would like to highlight that our database will not just be a collection of, or an integration of whatever is out there in terms of data, but the idea is that we have a type of characterization or parameterization of data. So to include the three different pillars that I mentioned, so the EcoBIM database and the EPDs and lifecycle inventory, but then to organize it and to calculate it further so that it shows, for example, environmental impact categories, and also gives information for the design for disassembly criteria. Then store all of that in the database, and that then this database can help for the execution of the demonstration projects. But the idea is here that also there will be some kind of feedback loop from the demonstration projects back into the database, so that there's kind of a learning process. Yeah, next slide, please. If you talk about circularity or circular construction, obviously it's very important how to measure circularity. The Circular EcoBIM project is an implementation project, so we want to use what other very intelligent people have done on that topic and implement it and show the strengths and weaknesses and try to improve it and make it more practical. So important references for measuring circularity are the Ellen MacArthur Foundation. You probably all heard about it. They developed the material circularity indicator that considers the amount of virgin material, the amount of unrecoverable waste, and the lifetime of the product. And then another very interesting reference is the so-called building circularity indicator that was developed by a H2020 funded project called Drive Zero. Here they use the material circularity indicator and kind of scaled it up by including also disassembly factors and the level of importance of the different elements within the building. So on the right, you can see a little diagram that shows how two important topics of circularity, namely these indicators or material circularity indicators and design for disassembly, are related. So they describe different things, but they're very intimately related. That is, that they both rely on the bill of quantities, and one is needed for the other. However, the circularity indicator is just a number, usually between 0 and 1, that kind of wants to quantify based on usually qualitative criteria how circular a material, a product, a system, or a building is. Next slide, please. A couple more words on the design for disassembly criteria. So it helps to quantify the amount of recoverable waste material and its quality in a building. And we believe it will be very important to define practical criteria for the design for disassembly. As I mentioned, we will base that on existing work by the Drive Zero project and also by the kind of famous reference that is Dumicevic, who wrote a doctoral thesis about this. However, we will use the more simplified version that includes 4 different types of criteria for disassembly. These 4 types are types of connection, accessibility, crossings, and integration of objects, and form containment. And we want to make a practical guide that shows this criteria and that gives examples that we can then pass on to building managers or users of the platform, so they have a better idea of how to evaluate these different criteria. Thank you. That's it from my side. And then I'll pass on to Professor Aguiar Costa, who will tell you more about BIM LCA.
Thank you very much, Verena. The Circular EcoBIM project aims to develop a BIM-based tool which will support circularity and LCA analysis of buildings and will help users optimizing their project's performance in this regard. As you know, and as Antonio has already said, building information modeling is a new technology and an integrated methodology to support projects' life cycle and improve the productivity and efficiency of the EC sector. And its use is becoming central to every project, and it's enabling the potential of digital design and construction. However, there are several gaps that should be addressed. The interoperability issue, which is crucial to guarantee the good communication between different tools and software. The lack of ontologies and classification systems, which are needed to structure and organize information and product data. And the lack of rich libraries, which allow easy access to structured information in a standardized way. This project aims to give an answer to these gaps, and the BIM-based tool is one of these contributions. Next slide, please. The development of a BIM-based tool like this requires facing several specific challenges. First of all, we need to map circularity and LCA processes. And this means identifying exchange information needs. And we must understand the analytical models behind this analysis, the involved variables, the indicators to be calculated, and the flow of information throughout the processes. Then we need to identify all the information involving these processes, which must be adequately classified. This is an example of how we convert the previous analysis into a BIM-based tool. We made this simple prototype to prepare our plan of work that reads the information contained in the model, reads its elements and materials, its quantities such as volume, area, etc. And we analyzed if they have environmental and economic information or not. Then the prototype that we developed allows the users to insert additional data into the model as observed on the right. All these parameters and values are automatically added to the model if we want. Of course, this is just a prototype, a simplified tool that we are using to test all the possibilities of the BIM and to guide what we need for the tool we are developing. Next slide, please. So if we implement the respective analytical models, the tool can give us the LCA, LCC, and circularity results we want, and can show us the 3D view of the life cycle impacts of the project per category. The elements in red on the right are the ones that contributed the most to the total impacts of the project, while the ones in green contributed the less. This is just simplified example, as I said, of the way to go. And particular attention must be given to the integration of the tool with existing databases and BIM libraries, and of course, the databases we will develop. Next slide, please. There are several problems to be solved besides the gaps we need to face and to give answer to in terms of tool development. But the main steps are already defined. Besides developing the tool, the project needs to create semantically rich BIM objects to support circularity and LCA, LCC analysis. Also, we need to further understand the design process to provide some semi-automatic tools or semi-automatic support to the user who will have an optimization-oriented support. That's all from my side. Thank you, and I will pass on to the next part.
Thank you very much, Antonio. My name is Rui Barata. I'm the responsible of Central BIM. Antonio Lorena, please, can you give me, okay, yeah, I have access. Thank you very much. Like my colleagues have stated earlier, the architectural, engineering, and construction industry consumes a significant rate of materials such as steel, aluminium, copper, plastics. Thus creating a large reservoir on secondary raw materials in buildings. New digital tools such as BIM, Building Information Modeling, enable data management along the life cycle of a building. So we can enable circularity by making use of this enormous database of information that we construct in the first stages of every design of a building. The early design stages play a crucial role in waste reduction. The reusability of building elements, as well as in the increase of the recycled potential. But what are these altering tools and digital twin? What is what? A digital twin is a digital replica of a living or non-living physical entity. A digital replica of physical assets, processes, people, places, systems, and devices that can be used for various purposes. A BIM altering tool, such as Autodesk Revit or Rhinoceros, different brands, permit us to start to create this digital twin, delivering a central model with data and information for specific domains, such as architecture, structural, HVAC, MEP engineering, cost calculation, and project management, and so on. But in the operation and maintenance stage, the users and facilities managers need tools to better understand and manage their facilities and decide what to do with their assets. In order to obtain information-rich BIM models, providing comprehensive knowledge based, including both geometry and parametric attributes, requires further data repositories with structured information on built-in materials according to the building age and historic data. The tools for the operation and maintenance stage must be interactive, real-time, 3D and 2D. This is our vision. In this way, they permit a gamification-based concept for automatic maintenance of BIM models throughout the life cycle. This will allow assessment of structural changes and changes of building elements and of user behavior, such as opening a window or switching on lighting. User participation thus enables both reduction of energy consumption together with the automated update of both the digital twin and materials by embedding of new building elements or deleting of the demolished ones. Why interactive? Because the user must have the ability to interact with the building and systems from a device of their choice, like a PC, a tablet, a phone, with virtual reality, VR or AR, augmented reality. Real time, because we want to receive in the moment every event that occurs for example, a fire alarm, and actuate accordingly. 3D is amazing, yes, but don't forget, we can't forget 2D. Many times people under-evaluate the power of 2D, but for example, a schematic in 2D is usually easier to the user to understand than the real 3D constructed system with all of its complexity. There are various ways to create a digital twin. One of the best tools that help us to create a digital twin of an existing building is laser scanning. I will pass to my colleague Nelson Rodrigues, but firstly, I want to mention that one of our demonstration cases is related to Vic Properties. That is a land of Matinha, a former Petrogal refinery. So with the intention of creating a digital twin, we already did a survey with laser scanning technology of the existing structures of 4 mega gas tanks, and I think one of them will be used for an hotel. Am I right, Nelson?
Yes, you are, Rui. Thank you. My name is Nelson Rodrigues, and I'm representing Vic Properties and my colleagues, Luís Gamboa and Luís Cabecinha. And first of all, I will thank you for inviting us to this webinar and to be part of such a revolutionary study. It's one of our principal policies to contribute to the decrease of the carbon footprint. Can you, next slide, please? So our departure for the demonstration project is based into single prototype projects developed by our partners Atelier dos Remédios, being the first based on experiencing vertical and horizontal repetition of a type of house and its controls of the constructive elements and equipments that composed it. And the second, next slide, please. A real case that explores modularity, sustainability, and alternative construction systems and its constraints involved. After testing our approach on these prototypes, we aim to demonstrate on bigger 2-scale projects within our project in Vic Properties. So the first one, next slide, please. The first one is Matinha, Lisbon. It's a brownfield development on contaminated soil that will transform 31.5 hectares in East Lisbon into a greenfield urbanized area. As Rui said, this is completely, this was a former gas plant and refinery as well. So it's in the south part of Parque das Nações, Expo 98. So we are talking about in 260,000 square meters for residential usage, 1,966 new units, 65,000 square meters for commercial usage, 15,000 square meters for a new hotel. The hotel that Rui was talking about. We will build the hotel inside we will use the exterior structure from the gas holders. We maintain that, and we'll build an hotel and using 2 gas holders. We'll divide this in 4 stages, and the construction is due to start next year, 2021. Next slide, please. The other project that we are working on is Cidade do Pinheirinho. It's in Alentejo. 200 hectares in Compota, Grândola. Grândola is a city almost 120 kilometers south from Lisbon. We have 197,000 square meters of gross constructed area, 450 villas, 250 apartments, 1 5-star hotel, and 1 18-holes golf course and clubhouse. As well, the construction is due to start next year, 2021. Thank you.